Welcome to an example on how to use the method of undetermined coefficients to solve a linear second-order non-homogeneous differential equation. Which means we'll be solving a differential equation in this form here, and the general solution will be in this form as we saw from our previous lesson. So the steps for using the method of undetermined coefficients will be: number one, solve the corresponding homogeneous differential equation given here, where it's in the same form but it's equal to 0. And then the general solution to this homogeneous differential equation from this step will give us the first two terms of the general solution to the non-homogeneous differential equation. And this is sometimes called the complementary function. Then we'll use steps 2 and 3 to find big Y sub p, a particular solution. So what we'll do for step 2 is guess the form of a particular solution to the non-homogeneous differential equation based upon the form of g of x. And this function will have undetermined coefficients. And then we'll use this function to perform substitution into the original non-homogeneous differential equation, and then solve for the undetermined coefficients, which will give us big Y sub p, and therefore give us the general solution to the non-homogeneous differential equation. And this method works best when g of x consists of polynomial functions, exponential functions, or sines and cosines. So let's take a look at our example. The first thing we should recognize is that we do have a linear second-order non-homogeneous differential equation, and g of x is a polynomial function, so the method of undetermined coefficients is an appropriate strategy. So for our first step, we want to solve the corresponding homogeneous differential equation, which should be y double prime plus 2y prime minus y equals 0. And now from here, since the coefficients are constants, or the differential equation fits this form here, we should recognize that we can solve this homogeneous differential equation by using a characteristic equation, or the equation ar squared plus br plus c equals 0, where a is 1, b is 2, and c is negative 1. So the characteristic equation would be 1r squared, or r squared, plus 2r minus 1 equals 0. And unfortunately, this is not factorable, which means we'll have to solve this in terms of r using the quadratic formula. So we'll have r equals negative b, or negative 2, plus or minus the square root of b squared, or 2 squared, minus 4 times a, which is 1, times c, which is negative 1, divided by 2 times a, or 2 times 1. So here we have r equals negative 2 plus or minus, this would be 4 plus 4, 8, divided by 2. And since 8 is equal to 4 times 2, the square root of 8 simplifies to 2 square root 2. So we have negative 2 plus or minus 2 square root 2 divided by 2. To simplify this, we'll break it up into two fractions. We'll have r equals negative 2 divided by 2 plus or minus 2 square root 2 divided by 2, which is negative 1 plus or minus square root 2. And since we have two real solutions to our characteristic equation, the general solution to the homogeneous differential equation will be in this form here. And notice how this will give us the first two terms in the general solution to the non-homogeneous differential equation. So from here, let's call it y sub c. The solution to the homogeneous differential equation would be c sub 1 times e raised to the power of r sub 1 times x, which will be negative 1 plus square root 2 times x, plus c sub 2 times e raised to the power of r sub 2 times x, or negative 1 minus square root 2 times x. Which means the general solution to the original non-homogeneous differential equation will be in the form y of x equals these two terms plus big Y sub p, a particular solution to the original differential equation. And because the left side of this differential equation is equal to a quadratic function, big Y sub p with undetermined coefficients will be a quadratic function. So we'll say big Y sub p, or our guess, will be ax squared plus bx plus c. So now we'll use this function, find the first and second derivative, perform substitution into the original differential equation, and then solve for a, b, and c, which will give us big Y sub p, and therefore we will find the general solution to the non-homogeneous differential equation. So let's go ahead and do this on the next slide. So if this is big Y sub p, we'll now find the first and second derivative. So big Y sub p prime would be equal to 2ax plus b, and big Y sub p double prime would be equal to 2a. Now we'll perform substitution into the original differential equation and then solve for a, b, and c. So for y double prime, we'll have 2a plus 2 times y prime, which will be 2 times 2ax plus b, and then minus y, which will be minus this quadratic here, so minus the quantity ax squared plus bx plus c, and this must equal x squared minus 5x plus 6. And now we'll clear the parentheses on the left, so we'll have 2a plus 4ax plus 2b minus ax squared minus bx minus c. And now we'll group the x squared terms, the x terms, and the constants. So notice how there's only one x squared term, and there are 2 x terms, and there are 3 constant terms. So we'll have negative ax squared, and now we're going to factor out the x from the 2x terms, so we'll have plus the quantity 4a minus b times x plus the constant terms, which will be 2a plus 2b minus c. This is still equal to, let's say, 1x squared minus 5x plus 6. And now from here we can set up a system of equations to solve for a, b, and c. Notice that negative a must be equal to positive 1, 4a minus b must equal negative 5, and finally 2a plus 2b minus c must equal positive 6. Well, if negative a is equal to positive 1, we know that a is equal to negative 1. And next, if 4a minus b must equal negative 5, and a is negative 1, we know that negative 4 minus b must equal negative 5. So if we add 4 to both sides, we'd have negative b equals negative 1, so b equals positive 1. So we know a is negative 1, and we know b is positive 1. And finally, we know that 2a plus 2b minus c must equal positive 6. Well, again, if a is negative 1, this would be negative 2. B is positive 1, so we'd have plus 2 minus c must equal 6. Well, these sum to 0. Negative c equals 6, so c equals negative 6. Now that we know the values of a, b, and c, we found the coefficients of our particular solution. And since we have a particular solution, we now have the general solution to the original non-homogeneous differential equation. The particular solution, big Y sub p, is going to be equal to negative x squared plus x minus 6. So the last step, we'll substitute this function here for big Y sub p in our general solution. Let's go and do this on the next slide. The general solution to the non-homogeneous differential equation will be equal to c sub 1 e raised to the power of negative 1 plus square root 2 times x plus c sub 2 e to the power of negative 1 minus square root 2 times x plus big Y sub p, or minus x squared plus x minus 6. Okay, that's going to do it for this example. I hope you found this helpful.